Find the interval in which the given function is increasing and decreasing. So the given function is x minus 1 the whole cube into x minus 2 the whole square. If the derivative is greater than 0, then it is increasing. If the derivative is less than 0, then in that interval it is decreasing. So let us find the derivative. F dash of x is equal to, treat this one as u and this one as v, 3 into x minus 1 the whole square into x minus 2 the whole square plus 2 into x minus 2 into x minus 1 the whole cube. So we will take common. Common is x minus 1 into x minus 2. X minus 1 the whole square is common. So balance is 3 into x minus 2 plus 2 into x minus 1. So this is f dash of x. On further simplification, we have x minus 1 the whole square, x minus 2. So here we have 3x minus 6 plus 2x minus 2. On further simplification, we get f dash of x is equal to x minus 1 the whole square into x minus 2 into 5x minus 8. Now we will draw the number line to figure out where the given function is increasing and decreasing. Okay. So first we have the critical point as 1, 2 and 8 by 5. 8 by 5 is approximately more than 1, 8 by 5, and here we will mark 2, more than 1 and less than 2, right? So all the coefficients are positive, so you can start from positive. Then the power is odd, so change the direction. Again the power is odd, change the direction. And the power is even, so we will follow the same direction. Now let us see where the given function is increasing. F dash of x is greater than 0 in the interval minus infinity to 1 union 1 to 8 by 5 union 2 to infinity. Where the f dash of x is less than 0, that is 8 by 5 to 2. Now for a function you can close all these intervals. You can close all these intervals except the infinity alone. So here also you can close for the function. For the derivative it should be open interval.